Good morning, everybody. Anyone unmute yourself and tell me, are you able to see the screen and audible?
Yes, sir.
Nice. Okay. Okay. Last class we discussed about the intermediate to modifying system. This is the second portion in the fourth module. So in the introduction means intermediate model means which receives the signal from the primary stage, then amplifies the signal, improves the signal, and then it is fed to the final stage. That is the terminating stage. So there you can read the result of the measurement. That may be temperature, pressure, current, resistance, or anything. So that the intermediate, the name itself indicates intermediate, which receives the signal from the primary stage, then the signal is amplified, converted into analogous signal. Again, the analogous signal is converted into voltage signal. Then it is fed to the final stage or the terminating stage where you can read the result of the measurement. That is temperature, pressure, or anything. So in that we studied mechanical system. So what are the problems arises while measuring the mechanical properties like pressure, temperature, like, so that is the first one is mechanical advantage or mechanical gain. This is that mechanical advantage can be defined as the ratio of input to the output. That is the input displacement to the output displacement. Again, you can define like this also. Mechanical gain, which is defined as the ratio of input to the output, input velocity to the output velocity. In the same way, so you have some reflected amplification in the system. That's the spring, worm, gear, and other mechanisms are used in the measuring instruments. There you have some inertia that is called reflected inertial that should be amplified. You have to neglect or you have to add that amplification for measurement. Next, come to the point, the temperature problem. So all of you know, if you conduct the experiment in the extreme low pressure or extreme low temperature or extreme high pressure, extreme high temperature, for example, in our room temperature, we have 25 to 30 degrees. Say, suppose if you go to some Gulf countries, you have minimum temperature of 45 degrees. Or if you go to US or any other country like Canada, so there, Russia, there you have minus 13 or minus 19 like this. If you conduct a measurement in the extreme low temperature and extreme high temperature, there should not be any thermal expansion or thermal contraction in the metal. Temperature problem. So that type of problem you have any affect the measurement. Next, come to the point scale error. For example, if you measuring pressure, so you are using 0 to 10 pressure gauge. So you need a 5 kg per millimeter square. But in actual practice, the pressure is 5, but the needle is showing 4.99 or 5.01. So the difference with the actual one, with the true value or true reading. So that is scale error. Next, come to the point for measurement of strain in case of bending of the beam, in case of shaft axial strain, or in case of torsional strain, you need input circuitry. Input circuitry. So that is the loading system. From that, you can load the specimen by using input circuitry. So there will be two types of input circuitries are available for measurement of strain.
One is simple current circuit or simple current sensitive circuit. The other one is alert circuit. So you have already studied in physics laboratory the Wheatstone bridge ballast circuit and the simple current sensitive circuit. Next, come to the point. So this is the ballast circuit used for loading the system in case of measurement of axial strain in the shaft, bending strain in the simply supported beam or cantilever beam, and torsional strain. So where you can use the strain gauges for measurement of strain, whether it may be axial strain, bending strain, or torsional strain. The Wheatstone bridge or Bella circuit used for measurement of strain. So what are the things present in Bella circuit? Just go through the one by one. That is the input voltage, that is the EI, and the ballast resistance RB, and the excited voltage coming from the measurement, that is EO, and the rheostat resistance K into R1. K is the constant. So this is the simple ballast circuit used for measurement of strain in case of measurement of axial strain, bending strain, and torsional strain. Next, come to the point. Wheatstone bridge. All of you studied in physics Wheatstone bridge. For example, in Wheatstone bridge, the same circuit used for measurement of axial strain, bending strain, and torsional strain. Say in this V-stone bridge, there will be four resistances R1, R2, R3, and R4 are connected like this. And this is the V is the input voltage and E is the excited voltage after measuring. See, first R1 by R4 equal to R2 by R3. Say in the V-stone bridge, you can use the strain gauge electrical. Say, next module, you have to study the strain measurement. There, you have to use the V-stone bridge for measurement of axial strain, bending strain, and torsional strain. So, you know the resistance of R1, R2, R3, and R4. Say, remove R1. Instead of R1, you connect the strain gauge, metallic electrical resistance gauge in place of R1. Then see the result. So what you have to do, first use the bridge circuit like this, adjust the circuit to read null balance. Null balance means that is the output from the measurement is 0. Then remove R1, remove the connection R1 and connect the strain gauge in place of R1 and see that the output is 0. That is, adjust the circuit to null balance. Then load the specimen, whether it is axial strain or bending strain. In case of bending strain, in a cantilever beam, load the beam with load 1 ton, 2 ton like this and see the output. The output is in ohms resistance. So then you have to convert that ohms into strain units, the resistance units into strain units. So like that, you can use the Keystone bridge circuit for measurement of strain in case of axial strain, bending strain, and torsional strain. Next, come to the point, very, very important. Before that, all of you write down the question. Explain briefly. Explain briefly in bracket. Write down circuit. In bracket, write down circuit. Close the bracket. Explain briefly explain briefly electrical intermediate modifying intermediate modifying system. Next line write down answer. Next line write down answer. Input circuitry. Input circuitry. Below that write down number 1 input circuitry. Below that write down simple current sensitive circuit. Simple current sensitive circuit. Below that write down subdivision A. Subdivision A. Balance circuit. Subdivision A. Balance circuit. For this question, you have to write balance circuit and write the diagram and name the parts of this circuit. That is excited voltage EI coming from the battery, the ballast resistance RT, and the rheostat R1 multiplied by constant K. For measurement, the excited voltage EO. Excited voltage EO. So like this, you can use this circuit for the measurement of strain. In case of axial strain, bending strain, and torsional strain. Next, write down subdivision B. Wheatstone bridge circuit. Subdivision B. Wheatstone bridge circuit. You clearly understand the working of Wheatstone bridge circuit while studying the measurement of strain in case of axial strain, bending strain, and torsional strain. Next, come to the point. Say the terminating devices. The name itself indicates terminating devices. That is the output coming from the measurement that you have to analyze, study, and monitor. So the terminating devices gives the result of the measurement that is can be understood by the operator or the human being or the required for monitoring the system. The name itself indicates terminating devices. That is nothing but the final instrument that gives the result of the measurement. Result of the measurement. That is the introduction. Next, come to the point, the mechanical intermediate systems. Mechanical intermediate systems. See, you are all belongs to mechanical engineering. Give me the good example for mechanical intermediate system. For this good example is speedometer in your two-wheeler or in your car. The speedometer, odometer, or the instrument that gives the reading, mechanical counter. See, all of you seen in the receipt book used for receipt. giving the receipts. In that, you have the numbers in the ascending order: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, like that. So that is the ascending order. The printing of ascending order, there will be an instrument is available. That's called mechanical counter. From that, you can read the numbers. So for this good example is speedometer or odometer, and in the printing press for printing of number of copies. So that is the mechanical intermediate system that gives the output in terms of numbers. So this is very, very important. Say in case of a speedometer, there will be 5 rings are there. On the circumference of the ring, there will be numbers. That is 1 to 9, again 0. So after movement of ninth one, it gives the movement to the preceding one. So that starts with 1. Again, which moves the 9, 10, and then which gives the movement to the preceding one. Again, that starts 1. So how the number moves in the ascending order, that is the mechanical counter. This is very, very important for mechanical engineers. All of you observe here, the numbers are marked 0 to 9. Next, come to the point, electronic counter. Say nowadays, everywhere in the shopping mall or in the stadium or anywhere, they use a magnetic or electrical detector to find out the, the dangerous item if you carry inside the shopping mall or stadium. So there will be electronic counter which has the sensors. If you move inside that counter, that gives the number 1, like that. The electronic counters are also used in measuring the number of persons passed through that area or passed through the counter. So for this is the very good example. That's in terms of numbers. That is, if you observe, if you see the cricket match, so they give you the capacity of the stadium is 1,85,000 people are watching the cricket. So how they count? They are not counting the head. That is, when they are passing through the counter, due to the sensor, there will be a disturbance in the circuit that reads the 1, 2, 3, like that. That is electronic counter. Next, come to the point, very, very important. Almost all the question paper, you have this question in the examination. All of you write down the question. Explain briefly the mechanical intermediate systems. Explain briefly the mechanical intermediate system. So answer for this question is below the write down answer subdivision 1 or subdivision A. Subdivision A, mechanical counters. Subdivision B, electronic counters. Electronic counters. Next, the terminating device. Tell me the very good example for terminating device is cathode ray oscilloscope. In turn, it is also called as CRO. CRO. So for this good example is your
TV, cathode ray TV. Many of you have Doom type of TV in your house. That is 22 inches, 29 inches like that. The size of the monitor, that is 22 inches or 29 inches, so like that. So in this and also in ECG, electrocardiography, in that also the output you measure in terms of waveform ECG, and also in echocardiography. There also they use monitors. So monitor is nothing but cathode ray oscilloscope or CRO. So what are the things present here? Just go through the heater. So here, this is the heater. In between the grid and the heater, there will be a tungsten filament. So I have not shown the tungsten filament here because the tungsten filament is on the other side of the CRO. And grid. So grid means it is just like a cup or the container which accepts all the electrons coming from the tungsten filament. And next come to the point, accelerating anodes. Accelerating anodes. And next, horizontal deflection plates and vertical deflection plates and fluorescent screen. The image you observe on the screen, that is nothing but fluorescent screen. Then come to the point. The principle of operation of CRO is like this. This is the heater. The filament is present here in the heater. Due to the electrical current, the filament starts to produce enormous amount of electrons. Enormous amount of electrons. All of you observe here, the dots which you observe here, this is nothing but electrons. And after that, there will be a grid which absorbs all the electrons coming from the tungsten filament, that is absorbed by the grid, and which make the uniform movement of the electrons from the grid. And next, accelerating anodes. The name itself indicates accelerate. That is the low intensity electrons into high intensity electrons. Acceleration. This anode makes the electrons to accelerate. And then if there will be any deflection in the horizontal direction, any deflection in the horizontal direction, that is the deflection of the electrons in the horizontal direction, can be controlled by using horizontal deflection plates. Many of you seen in the black and white TV, in the backside, they provided a knob. From that you can control the image in vertical direction as well as in the horizontal direction was possible in the black and white TV. So that is nothing but the horizontal deflection plate and the vertical deflection plate. Any deflection or movement of the electrons in the vertical direction, that can be controlled by using vertical deflection plate and make the image exactly on the center of the fluorescent screen. Fluorescent screen. So once again, the principle of operation, when you provide the electric current to the heater and the tungsten filament starts to produce the electrons. The electrons are coming from the tungsten filament, which is made uniform by using the grid, and then which is made to fall on the accelerating anodes, which excites the electrons, accelerates the electrons, and passes through the horizontal deflection plates and vertical deflection plate. Any deflection in the horizontal direction of the electrons are controlled by using horizontal deflection plate, and any deflection in the vertical direction that can be controlled by using vertical deflection plate. And exactly this dotted line indicates exactly at the center of the fluorescent screen you have the image. You have the image. A good example is a monitor of your computer, TV screen, ECG screen, any monitor. These monitors are made of cathode ray oscilloscope. All of you, please write down the question. Write down the question. Explain briefly. Explain briefly. Doodala. Tandi. Explain briefly with neat sketch the cathode ray oscilloscope or terminating device. Terminating device CRO. Terminating device CRO. What a question. List the applications. List the applications and list the applications and limitations. List the applications and limitations. Now I stop at this stage, and now all of you please enter your USN and name in the chat box. Prithvi?
Present, sir. Present, sir.
Okay, no problem. All of you, Pratham, unmute yourself. Pratham, Pritham D, Renil,
Yes, sir.
Vinayak, JH,
Present, sir.
Vedavyas,
Present, sir.
Swati,
Present, sir.
Prithvi,
Present, sir.
Karthik, Vinayak, okay, Yashwant,
Yes, sir.
Yashwant,
Present, sir.
Yes, sir.
Nitin, LM, Vinit SN,
Present, sir.
Prithvi, Sanjay, Rahul N, Pawan T,
Sir.
Vinay Patil, Pawan H,
Present, sir. Present.
Nitin GS,
Present, sir.
Shashank HS,
Present, sir.
Pawan Kumar GV, Pratham P, Pawan MC, Vinay Patil, Pritham D,
Present, sir.
Yashwant,
Yes, sir.
Vinayak,
Yes, sir.
Pawan H,
Present, sir. Present.
Prithvi M.
Present, sir.
Okay. I will continue in the next class. Now I stop at this stage.
Now you can relax.
Yeah.
Stop and relax. సార్ నిజాలు ఆన్లైన్ చూస్తారు కదా సార్
అవుదమ్మా